I'm back, and I finally have some good video ideas I can make. I have to make some new videos, and one that really went my way is one of my friends. He took a test, and I looked at it. Right, he showed me his test, and I see a couple problems that he missed. Right, and I feel like I can clarify because I feel like some of the mistakes he made were one of those mistakes that I feel like a lot of people are making. So I'm here to capitalize on that. So we're gonna be doing a couple problems that I thought were noteworthy, right? And we're gonna be solving them step by step. So this may take a while because I have a lot, but it's not even all of them too. It's a lot still. So yeah, tuck in. Let's start. First, y equals 3 cosine of x minus pi over 4 minus 2. So, and we have to graph that. So let's do that. Okay. What this 3 does to this cosine is it stretches it vertically. And the reason why that will happen is because whatever you can put whatever gibberish you want in cosine, right? It doesn't matter what you put in cosine. This cosine will always be between -1 and 1, right? This 3, when you multiply it with at most 1 and -1, you will get at most 3 and -3. So this function is going to oscillate between 3 and -3. So that's your maximums. But we're not only going to have 3 and -3, we're going to have 1 and -5. Why? Because it's a -2. So at most you're gonna get 1 from this cosine. It doesn't matter what the inside is, right? At most you're gonna get a 1 from this cosine. And whenever you get that 1, you're gonna get multiplied by 3. So it's gonna be 3 minus 2, which is 1. So it's gonna oscillate between, and the similar thing for -1. -1, -3, minus 2, which is -5. So it's gonna oscillate between -5 and 1. And one mistake that I noticed a lot of people do is that when they connect a cosine graph, they do this. This is wrong. The reason why cosine doesn't go in a line is because think of its slope, aka its rate of change. Cosine never change. The graph, the y values of cosine don't change at a constant rate. It isn't proportional to the rate of change of the angle. What that means is when you draw a unit circle, actually, cosine is actually the x coordinate. So this is actually cosine x, cosine theta, sine theta, right? And where there's an angle theta. It's a bad theta. That's theta, right? This will increase, this cosine will increase as really quickly when theta is near 0, right? Because this thing has a steepest, this angle can change the x coordinate really quickly. But when you change the angle similarly to this part over here, right, it's gonna change slower and slower, right? Basically, when I move theta, when I change the angle the same distance near to 0, the cosine theta is gonna change at a different rate compared to what theta is. Whenever you have straight lines graphically, that means that this, wherever theta is, doesn't matter. How much ever I change theta, it could be anywhere in the unit circle, cosine theta will change at the same rate. That is obviously not the case, as we've shown. So what that means, it's going to be curved. Because what else will it be? So let's graph it. One more thing we need to take into account now is this minus pi over 4. And all that's going to do is shift to the right. So I think my right, which is this way. It's going to shift it this way because if you think about it, the new 0, the new starting point, which is usually a 0, is going to be pi over 4. Because when I put a pi over 4 in, pi over 4 minus pi over 4 is 0. Cosine of 0 is your starting point, right? So let's actually do this about pi over 4. Because after that, after pi over 4, we're just graphing a normal cosine function. Right? This is 1. Let's say this is -5. Cosine of pi, and also the midpoint of cosine is 0, right? So it's going to be 0, cosine of 0 is just like the 0, right? It's going to be like 0. 3 times 0 is 0, so negative 2. So we know that negative 2 is the midpoint between the two. So negative 2. Right? Let me take out this pi over 4. I think you know what it is. So we know that cosine of 0 is actually 1. It isn't 0. So we know we're starting at the highest possible point, because remember, our maximum value isn't 1 anymore, it's 3. So we're going to start at this highest point here. And then when we add another pi over 2 from pi over 4, which is 3 pi over 4, let's just say this is 3 pi over 4, because whenever we add another pi over 2, we basically go back to the midpoint, right? Because cosine of pi over 2 is 0. Sorry, cosine of pi over 2 is 0. And I plug a 3 pi over 4 in, you're going to get a pi over 2, because you're going to get 2 pi over 4, which is pi over 2. And then when you plug in, and when you go pi over 2 again, you're going to get negative 5, because you're going to get negative 1 in the cosine, times 3 is negative 3, minus 2 is 5, and so on, so on, so on. So you can see the pattern now, which is probably like around here, because you're going pi over 4, add another pi over 2 is going to be on the opposite side, so here, yeah, and then over here, and remember, we're going to have it be curved, because it's cosine. Next question. Okay, next question. This is an identity that we're gonna have to prove or disprove. So we usually the goal is to really end up with a statement that is pretty obvious, that no one can really disprove, like 1 equals 1, or cosine x equals cosine x, or apple equals apple. If we end up with that, we are done, and we can put a happy face. And since we're trying to prove something, let's put down the PF, right? So whenever we're let's use some already known ideas, right? We see a squared here, and we see another squared here. So let's multiply that thing out. We're gonna have and you get how we do this. We're gonna FOIL this essentially. This squared plus 2 times this times that, and this squared. Remember, the negative goes away because we're squaring it, and we're doing the same thing over here. And when you do it properly, you're gonna get this. Now, very, very nicely, this minus this will go to 0. Why? Because it's the same thing. 2 minus 2 is 0. Same thing, 2 sine x cosine x minus 2 sine x cosine x is 0. And one thing we know is we have a cosine squared x plus sine squared x, right? That is 1 plus cosine squared x plus sine squared x, which is 1, and that equals 2. And I can prove, there's a lot of reasons, there's a lot of proofs for 1 plus 1 equals 2, but that's it. Right? And we're done. Next question. We have sine squared x minus 3 sine x equals 0. This is a standard algebraic expression, but we have a sign in there. Luckily, there's no cosines or tangents, no other trigonometric functions. We only have a sign, which means we don't need to use any identities. We can just start solving. And since you only have sign, one thing you can do is you can change a variable and solve it in terms of sign. Basically, if you use sign right now, it can get confusing. So what I recommend you do is you add a new variable. Let's use alpha. I don't know why. Alpha equals sine x. Right? So now we can solve in terms of alpha and then solve in terms of x. We're basically not trying to confuse ourselves. So alpha squared minus 3 alpha equals 0. Right? This is a quadratic, remember. Doesn't matter what alpha is, doesn't matter what x is. This is a variable, this is one variable squared, there's another variable times a number that equals 0, that's a quadratic. Let's solve this quadratic. Factor out alpha. Alpha equals alpha minus 3. That equals 0. And then one has to equal 0 or the other one has to equal 0. So alpha has to equal 0 or alpha has to equal 3. Now be very careful. Remember, we're trying to solve for x which has sign. 3 cannot be possible from sign because the maximum value sign can produce is 1. So 3 is you can actually find a solution for sine x equals 3, but you would actually have to use an imaginary number and your imaginary definition of sine, which you can get from Euler's. Long story, but the point is, in the real world, like the real number set, 3 is not possible for sine x, so we're going to x that out. So we have alpha equals 0, and remember, we're trying to find x. Alpha is just something we just used to help us solve that quadratic initially. So we have 0 equals sine x, right? So we basically taking the inverse sine of 0. And I don't remember, I think on this test there was a domain restriction, but let's just take elementary angles. Basically that is the angles between 0 and 2 pi, like the small ones, because you can technically keep on rotating. You can 4 pi, 6 pi, 7, but like we're just taking 0 and 2 pi. So the angles that are equal, the angles with sine x of that angle equals 0, right? Between 0 and 2 pi is 0 and pi. So x can equal 0 comma pi, because sine of 0 is 0, sine of pi is 0, sine of 2 pi is also 0, but I'm going to ignore that. That's in my definition, just turning the clock. But essentially these are the things, these are the solutions. Or another way you can represent all real solutions, you can say x equals 2n pi, or n pi, or actually just be n pi. Never mind. That's just another way to do it. You can say it's n pi, where n is a integer. Basically, that just means that for all integers, you can multiply pi, and that would be a solution. So any integer you can name of 0, 1, 2, 3, 69, 400, 1342. If they're an integer and you multiply it by pi, that will be a solution. That's what this means. It's fancy notation, but that's another way you can represent solutions. Next question. Okay, our next questions, which are, we're going to use sum and difference identities, which it was on the test, so I'm telling you right now. Sum and difference identities to find the exact values for these angles, for these cosines and sines. Now, sum and difference basically is when you have something plus another something, or something minus another something inside the sign, and you can break that apart. There's a way you can do that. The proofs are, I think they use geometry, but long story short, one thing we can do for these two angles is that we can try and represent the number as a sum of two numbers we like. In other words, people know that 30 plus 45 is 75, but I know 75 is 30 plus 45, right? That's the idea. Cosine of 75 is the same thing as cosine of 35 degrees plus 30 degrees, my bad, 30 degrees times 45 plus 45 degrees, right? Now we have this broken apart in terms of two other angles. Let's use the sum and difference. So you know that this is a plus, and whenever you have cosine, the sign changes, so it's going to be a minus, right? And cosine, it goes cosine, cosine, sine, sine. So it's going to be cosine of the first angle, which is 30, times cosine of the second angle, which is 45, right? Minus sine of the first angle, which is 30, sine of the second angle, which is 45, right? Now, You probably know all of these because we're supposed to memorize these. 30 cosine of 30 is I think it's the square root of 3 over 2 times the cosine of 45 is root 2 over 2 minus this is 1/2 times root 2 over 2, which is the same thing as, we can multiply them together because they're the same exponent, radicals. So root 3 times root 2 is root 6, and 2 times 2 is 4. So that's going to be root 6, and we notice we're going to have the same denominator, so I'm going to subtract them in the same step too. Square root of 2, because square root terms 1 is square root 2, and 2 times 2 is 4, 2 times 2 is 4, same denominator, so don't worry about anything, 4. Now, let's do the same thing here. We know that sine is nothing but 45 plus 60, so sine of 105 is nothing but sine of 45 plus 60. That's a better way to say it. Sine of 45 plus 60, right? So let's do the sum and difference again. This time we're going to keep the plus because it's sine, and we're going to do the wrapping. So that's going to be sine of 45 cosine of 60 times cosine of 45 sine 60. So let's do this. Sine of 45 is the square root of 2 over 2 times the cosine of 60 is 1/2. Okay? Plus cosine of 45 is square root of 2 over 2 times square root of 3 over 2. That's sine of 60. This is going to be, we already got that actually over there. So it's going to be the square root of 2 over 4 plus square root of 6 over 2 over 4. And now we can add them together, square root of 2 plus the square root of 6 over 4. Next questions. Okay, this one on the test that he gave me, it was some weird question about a pier and a seashore, and I had to reread it like 15 times to understand what the question was asking. But really when I finished out reading the question, it was asking this. We have a triangle over here, we want to find the length of this side. We know the length of this side is 100 feet. This angle is 37, this angle is 85. That's all I get. So yeah, let's do it. Now one thing we know is we can solve for this angle because that's a complementary angle. Well, actually, supplementary angle, I think that's the one with 180 degrees. So you basically can subtract 180 from 85 to get that, which is, quick mental math, 95. 95 over here. So let's rewrite the triangle now. This is 95. This is 35. 37 actually. So now we know that this side is 100 feet. We want to know this side. Now this is obviously something begging me to do law of sines. And in order to do law of sines though, we want this angle because we can use that for the 100 feet thing. So to find that angle, we can just use the theorem that says that you can add the angles of a triangle and make it 180. So we can say that 180 minus 37 plus 95, that equals the third angle. Let's call it C angle. So 37 plus 95, let's do some quick arithmetic. That's going to be, well, we're going to put a 1 there. It's going to be 2. 4 plus 9 is 13. 132. 180 minus 132, that is equals to, let's see here. That's 48 degrees. Yeah, 48 degrees. So this is 48 degrees. Right? So now we can use law of sines. We can say that the sine of 48 degrees over 100 feet equals the sine of 37 degrees over, let's just say question mark. So let's cross multiply and divide that sine over. So question mark sine 48 degrees equals 100 times sine of 37 degrees. And then question mark would be 100 sine of 37 degrees over sine of 48 degrees. And that is your solution. Now in the test, I think it asks you to round to the nearest 10th, so make sure you do that. And I think you have a calculator on this section. That would be brutal if they wanted you to do this by hand. I don't even know how you do it by hand at that point. But yeah, this is your answer. So next question. Okay, another question they were asking is convert that to rectangular coordinates and explain the graph or something like that, or just state the. I'm just gonna state what type of a graph it is, like either was a cosine wave, a quadratic, a quintic, logarithmic. I'm just gonna explain that, but it should be pretty obvious once we solve it. But the key with this is that you just gotta have a good strategy, and that means is you also gotta know like the 3 conversion rates, the 2 ways you can convert this to x and y's, which is r squared equals x squared plus y squared, r cosine theta equals x, r sine theta equals y. If you know these 3 and you're able to get your equation in terms of either r squares, r cosine thetas, and r sine thetas, you can replace everything with an x squared and a y squared, or an x, or y. So that's our strategy. Our strategy is to only have either r squares, r cosine thetas, or r sine thetas. Once we have those, we can just substitute all of these, and we're done. So let's do that. We have a secant. Let's rewrite that. Let's rewrite that as r equals 2 over cosine of theta. Now, one thing I do notice, if I can do this in one fell sweep, r cosine theta is x. So if I get an r next to this cosine theta, I'm done for that one. And likewise, if I get rid of this r, I'm also done. I can do that both in one sweep if I divide. Actually, if I multiply the entire thing by 1 over r. If I do that, these r's will cancel out, and this r will come to this cosine theta, which I can later replace with an x. So I would get 1 equals 2 over r cosine theta, which is x. Now you just multiply the x over, and you get x equals 2, which is a vertical line, and it'll look like this. It'll look like that. So yeah, this will be x equals 2. Yeah. Next questions. Okay. Next question is, we're gonna have this thing. I don't even know what this is. That's the point. We're gonna have to find what this thing is and explain stuff about it, which I'm gonna do anyways. I don't remember actually if it's on the exam or not, but I'm just gonna explain it. So look, we have an x squared, a y squared, a y, and an x, which means we can complete the square and we can get something more compact, which will probably serve our purpose much better. So let's do that. Let's group the x's and the y's, right? Let's get this 3x squared minus 12x, and I put a plus a blank, okay? Then we get a plus 5y squared plus 30y plus a blank, that equals 0. Okay, now keep in mind we are going to factor out a 3, right? So we can complete the square in a somewhat piece, or in fact, actually I don't think I'll do that. So we just gotta like divide 3 on everything so we can remember to multiply 3 back. And it sounds complicated, but I'll explain everything. So remember, we're just gonna have a 3 outside. X squared minus 12x, that's 4x now, minus 4x plus blank plus 5 times y squared plus 6y plus blank, that equals 0. Now, let's try and complete the square. What number would I have to add here in order to get a perfect square? That is, I need to divide this number in 2 and square it, because that is going to be the 2ab, and this will be the b squared. So if I divide this number in 2, I get 3, and I square that, I get 9. Y squared plus 6y plus 9 is a perfect square. Now remember, we factored out at 5, and if I just add a 9, I'm changing the entire thing. So realistically, in order to make sure I'm not changing anything, I have to add a 45 actually. I'm gonna still add 9 here. But remember, 5 times 9, and we gotta add that again. So we're gonna add that's actually a 42. So let's put a 42 on this side. I completely forgot about that. I'm so sorry. Negative 42, negative 42, plus 45, right? Because we added this 9 here, and 5 times 9 is 45, so we're adding a 45 here. Same thing on this side. Minus 4x, that we're going to divide that by 2, which is negative 2, and then square that is 4. So 4, because this will be a perfect square now, that'll be x minus 2 squared. Remember, 4 times 3, that's 12, so we're going to add another 12 here. Perfect. So now let's evaluate this constant, which is going to be this is going to be negative 42 plus 12, which is negative 30, plus 45, which is 15. This is going to be 5 times y plus 3 squared, plus 3 times x minus 2 squared. Yeah. Now, remember, this does not look like a circle because circles do not have these 5 and 3s. They have only like a 1. So this means this is an ellipse. Which means we gotta make sure this is a 1 over here. So let's divide everybody by 15. Simplify, this 3 over 15 becomes 5, x minus 2 squared over 5, plus y plus 3 squared over 3 equals 1. This is your major axis square, which I think the major axis length would actually be square root of 5. This would be your minor axis length, that is square root of 3, and your vertex is 2, negative 3. So this is an ellipse actually. Yeah, next question. Okay, I'm gonna be real. I thought it was a pre-calc class, and when I saw limits, I was surprised. But times can change, and I guess limits, other than L'Hopital rule and calc, don't really have a place in calc. Most of it is algebra based or pre-calculus based, I guess. So yeah, I mean, it kind of fits well, I guess, limits. So, well, limits, let's do that. So our limit is, we're trying to get to a value that doesn't exist. Let's figure that out. When I plug in a negative 2 here, I'm going to get negative 2 over, negative 2 plus 2 is 0, over negative 2 squared cubed is negative 8 plus 8 is 0. 0 over 0. It is indeterminate, which means we have to do more work to figure out what the actual answer is. Indeterminate means you cannot draw any conclusions from that. This is something you cannot go any further in. Either you, like in infinity, like if you just get infinity, that's not indeterminate, that's just infinity. But 0 over 0, infinity over infinity, 0 to the 0, 0 to the infinity, all of those things are going to be indeterminate, which means you have to use more work. More work meaning let's factor. This is a sum of cubes. So I'm going to use my beloved SOAP acronym, same opposite plus. Which means we're going to get this thing, we're going to put 2 brackets in. One big bracket, because the trinomial is going to be there, because it's a cube. Right? Same opposite plus means if I'm going to basically, first I'm going to take the cube root of that and copy it down, which is x. Take the cube root of that and copy it down, which is 2. Same thing here, I'm going to put that over here and over here too. Now, for the center, I'm going to multiply the 2, which is going to be 8. No, take the cube roots, we're going to multiply the cube roots back, which is 2x. Then we're going to do same opposite plus, right? So basically that means we're going to copy down the same sign, at plus, take the opposite, which is negative, and then do a plus. Same opposite plus. And we're going to put the x squared plus x plus 2 down because we can't really do anything. And guess what? Go to 1, which means they cancel out. So now we get this. Now the thing is, whenever I plug a negative 2 in, these two are primarily responsible for making it go to 0 over 0. Because these two are basically, whenever you plug a negative 2 in, you get a 0. So now that we got rid of them, we can We can only focus on this and we'll actually get an answer now. So let's do that. 1 over negative 2 minus 2 times negative 2, which is plus 4, plus 2, which is 4 plus 2 is 6, minus 2 is 4, so that's going to be 1/4. So that is your limit. Now, this one is slightly different. It's actually supposed to be a 5 minus over here, my bad. So, usually, whenever you have limits like these, you're supposed to factor them out and get an indeterminate. But remember, the first rule of limits is to always plug it in first. Plug the value in first. And since you have a 5 minus, it's probably even better idea to plug it in. And I'll show you why. So, limit as x approaches 5 minus, which basically means from the negative side or from the left, like this way. Actually, no, it's this way from your camera. The perspective is messing with my head, but it's from this thing is actually from the 0 side, like where the 0 is, we're going from that side. So we're gonna go from like 4.9, 4.99, 4.99999, right? So when I plug a 5 minus into x, I get 5 minus, which I'm gonna basically do in a very unrigorous way, is 4.9 repeating. You get that? Because we're going closer and closer to 5. This is basically, right? And then 5 minus 5. That isn't 0, technically. 5 minus is really 4.9 repeating. Basically, we're getting infinitely close to 5, which is 4.9999999, right? And if I subtract a negative 5, I don't get 0. I get negative 0.00000000 repeating 1, like that. 0.00001. Let's use that unrigorous way. I'm just going 0.001. Okay. Now, whenever you have this, and you put that in the denominator, with any finite number that isn't this, you get infinity. That's just how it works. Like if it isn't like some infinitely small number like this, right? And you get like some normal number, like a somewhat normal number like 4.9, right? 5 minus, that's infinity. It's gonna blow to infinity. But remember, we have a negative. So this will actually go to negative infinity. And that is your limit. Done. This was a long test, and those were not the only answers that he missed, or I thought everyone else would miss, and Del what. And please comment, like please ask me, in fact, like if you want more, because I'm willing to do it. And yeah, have a nice day. I hope this thing helped you.